Okay, so this tutorial is going to walk you through three different scanning applications. Two are phone-based and one is sensor and computer-based. So Trnio is an amazing app, but it is only available for iPhone 6S or later. I've actually used it with the 6S and it does a really good job. They are in beta testing for Trnio Pro that will make use of the LiDAR in the newer iPhones. So keep an eye out for that. It's super cheap. It's $4.99. It's a great option. If you don't have an iPhone, however, less becomes less of the field kind of narrows down. And that's just, it's really hard to make consistent scans with vastly hardware that varies vastly and cameras that vary vastly. One option, if you do have an Android, is called Skanect, and it's a PC based, although they do have apps that work with the mobile tablets and sensors that work with mobile tablets. It also works with the Microsoft Kinect sensor, which is what I demo in this tutorial. There is a free version of the application. If you do have a Kinect sensor on hand, not all the sensors work as well as I've tried. I have a V2. I've never had the V2 Kinect sensor work. And I kind of think, I forget even if it's supposed to. There's also different model numbers for the Kinect. And I've found that the 1414 model number of the V1 is the only one that has given me consistent results with kind of third-party apps like this. The free version does limit you to saving OBJ files with or exporting your files with a 5,000 polygon limit. It's the app itself is 120, and then the sensors that they sell are $4.99. It's an infrared based sensor. So one of the issues with Trnio is that you have to be scanning in pretty consistent and really good lighting conditions because it's photogrammetry. It's the photos, the RGB photos that are driving the scan. So if you have harsh shadows, reflective surfaces, you'll get erratic results with your scan. And then In3D, which is a freebie for iPhone with true depth sensors only. But it's a great option if you want to do self-scanning. It's the only app that I found where you literally kind of hold your arms out in this kind of modified T 45-degree angle and just kind of walk yourself around, and it makes a 3D scan and stitches it back together pretty beautifully. So those are the apps. So let's jump into it. And I think I'm going to start here. I start here with Skanect. All right, so I'm going to use a program. It's Skanect. It's free, but it limits the number of faces. So like each one of these little shapes right here in the green lines is a face. So it's kind of like pixel resolution. The more faces you have, the denser the faces, the more detail you have in your image. So when you use the free version of Skanect, it's going to kind of make a very, you lose a lot of detail. So it's limited to like 5,000 faces. So I'm going to just open up the app and show you from the app now. So that's the non-commercial version only, and it limits you to 5,000 polygons. But then it's also Windows and PC friendly. All right, so I need to plug in. So it just plugs into your computer with a USB. It also plugs into AC power. All right, so this is the Kinect sensor. It's made for kind of embodied gameplay. So like what it does, there are 3 sensors on it, actually 2 sensors, one's a receiver. So this guy you can kind of see is flashing. This is actually sending out an infrared spray of infrared dots. So not light visible to humans, but I guess somehow my camera can see it. This is an RGB camera in the center. And then actually I forget which one is the RGB and which one's the infrared, but there is a camera that is looking at an infrared camera that is looking at the spray that the Kinect sensor is spraying out. And the spray pattern of the Kinect sensor
And let me share my screen now. Looks kind of like a starry night. There's here, you can see it in this image. There are all these little dots and they're independently kind of spaced from one another. And you can also kind of see this like meta grid for the spray. So it's like spraying out in a square pattern, all of these little dots. And this is what the infrared camera is seeing. And it can tell, it knows where, kind of like a QR code where all these dots should be. But if you put an object in between the infrared dot and like a flat background, the dot will get displaced. And that allows the camera, I'm going to turn my camera off, stop video. That allows the camera to determine how far away that dot is from the sensor itself. So it can do things like create skeletons for gameplay, but then a bunch of, they made the SDK release kind of open source. And then all of these folks started writing like Skanect, which is a program, wrote a program that can take those kind of still snapshots from that like distance sensor and then stitch them back together to create a 3D model. So that's what we're going to be using, or I'm going to be using to demo. We have 2 iPads. So my demo today is using the Skanect, but I'm using the Kinect sensor. We have iPads, which have the added benefit of having a viewport on them. So I'm going to be kind of using the sensor and kind of looking back at the screen as I'm scanning to do this. But the iPads have the, the display and they're cordless. So the awkwardness that I'm going to be experiencing with this is nothing near like what you'd be experiencing with the iPads. All right, so when you open it up, you want to say like, what are you scanning? I'm scanning an object, and that kind of changes the bounding box, which determines how much data is the scanner going to be using. Like if it's going to create an imaginary box that's half a meter by half a meter. The aspect ratio, if you're like scanning a body and they're standing, you'd probably want to do it height times 2. For the demo, I'm just going to scan an object and normal. And then I press start. So here's the like different types of data that I'm getting. Hello. So you can see, all right, here's the RGB camera. So that's actually the middle one. And then the infrared is being kind of shot out of one side. That's giving us this kind of like distance map. So as I kind of move, closer or further away from the object, at a certain like distance, it's too close. It can't read that information, so it turns black. But then it's creating this heat map kind of around me of like distance away from the camera. And you can see the kind of like, it's making like a three-dimensional kind of spray. This is a spray of infrared dots, hitting my wall. So I'm going to scan these shoes. I did a test with the Trnio app, which I'll share, so you can kind of see the difference. The nice thing about the Skanect is that it's using distance, like the infrared data. So you don't necessarily need to have a particularly well lit object. So for all the photogrammetry 3D scans, you need like fairly consistent lighting. Shadows will kind of do strange things to your objects. Since this is infrared, it will incorporate the color data from the RGB camera, but the 3D model is actually being constructed from the infrared data. So it doesn't, it's not light dependent. You can scan in the dark, for instance. All right, so once I've kind of got it set up, I want to put my, I really wish I had, let me see if I can turn both on, because I think it's useful for you to see like what I'm doing. Get my camera, there we go. Boop. Okay. So I want to kind of place this on a flat, like resting surface, or that's kind of flat with my object. And I want to make sure that my object is in view and that it's not totally like black from, so that it's receiving some data. So I'm going to start from this perspective. I can kind of drag. I'm a little bit far away, so I'm actually going to get this, make sure it's kind of in the center of my bounding box, because it will not record data outside of the bounding box. All right, so that looks pretty good. And I'm going to start the record from the flat position. One of the things about this is that since it's a live construction, it can lose its place relatively quickly. So it's like building the 3D model in real time, rather than the photogrammetry apps, which are kind of, taking a bunch of images and then stitching them back together and then constructing a 3D model. So with this one, I would need to ensure that I'm keeping my object kind of in view. And I basically start kind of from hip height or from kind of shoulder height. And I just slowly kind of walk around my object. If you have a turntable, you can use a turntable as well. But you can see, I mean, it's worse with Zoom open because it's, trying to do a lot. So it's kind of pausing. If I move too quickly, it will lose its place. And since I'm attached to a cable, I actually can't make the entire revolution around. So I'm going to walk back around the other way. But as I walk back around the other way, I'm going to kind of raise my angle so that I'm looking down on the object, so that I'm getting more color, more data from different positions. All right. And then this will be the tricky part. So keeping my object in view. You can see why this kind of like photogrammetry and this like cordless based system is super preferable to this. So I'm just going to kind of try to sneak around the backside. And I'm doing this, you can't see, I'm sneaking around the backside, and then I'm going to kind of bring the camera up. And then if I want like really good data, I need to ensure like the inside of the shoes. It's like I'm like shining a flashlight, right? So anywhere there's a shadow from the infrared, like it's not getting color data. Anywhere like it's showing up red, whoop, oh no, come back. Anywhere it's showing up red, it's too close. So it's not getting data there, or there's a shadow there or something. All right, and then I might want to, since I've kind of been high on my passes, I might want to do another pass kind of on the low side, just so I can get the data from like underneath the shoes or something. And if I was doing a human, I'd be doing the same thing. And one of the things that I like to do is if I'm making kind of big moves, like because of the cable or for whatever reason, I can't kind of like get around my person, rather than look at, keeping the camera on their torso. So like, I would actually want to face the camera at the floor, like at their feet where they're standing, because that gives me 2 planes of resolution. And it's, much easier for the 3D scan to keep track of where it is when it's looking at 3 planes of resolution. All right, and then I want to end, like if I was scanning somebody and I wanted their face to be like highly detailed, I would end my scan kind of like doing like subtle passes like around their face. And in this case, like I'm going to just do kind of subtle movement around like the laces. And then I press stop when I'm done.
Okay, so once the scan has finished reconstructing, it basically laces together all of these kind of single, kind of like photogrammetry, but using that depth sensor data instead of the RGB color camera data. So you can see the path that I took kind of around the scan and the limitations of my scan because I was corded to a computer here. I didn't get around the back. But this looks pretty good. So the next thing that I want to do is I go into my process mode. And here is Skanect itself has some kind of algorithms that are optimized specifically for like managing large meshes, where like a lot of the other programs will crash if you try to do like some of these operations. Maya, lots of problems with Maya with these kind of large meshes, Blender sometimes. But these programs, I use these few operations in Skanect specifically. So the first thing that I do is move and I crop. And there are like a couple rotational options here. So you can go in and kind of like rotate by hand using the sliders and kind of get it close. And then you can use these kind of +1 or like +0.01s to really get it kind of dialed in. So that looks pretty good. Let's see if I can, yeah, what you're really looking for, like, so these corners are just higher. I might kind of increase like the depth. So this one's actually kind of, moving it up and down. And what I'm eventually going to be doing is like cropping the scan to this blue plane. So crop to ground. There's that little artifact there, but this function might actually take care of it. Yeah, it did. So that looks pretty good. I just didn't get the kind of color data or the data inside of the soles. So there's holes on the shoes, but that's fine. That also means that there's going to be holes kind of on the soles of the feet here. If like those little holes didn't, or if those little like islands didn't disappear when I said crop to ground, then or if you like had a scan with like pieces of furniture like around the scan that you didn't want to include, this remove parts will, when you run it, it will like get rid of any kind of little islands that are smaller than the given percentage here, and you can change that percentage. All right, so I'm going to export as is. So we're going to be doing 3 exports. The first export is, the kind of scan out of the cropped, but like not manipulated. So in order to share or export the object, you go to the share, the last button here. I'm going to say export model. I'm going to export it as an OBJ, and then the defaults. There's no color data yet. So I'm going to export as is, and then I'm going to say, let's make a new folder. I'm going to go into scans, and I'm going to make a new folder. I've done this before. Nike scan 3. And this will be just plain Nike. And then the next thing that I'm going to do is colorize the scan. And for 102 students working on the prosthetic assignment, I don't want any color data. In fact, you'll be, graded down if you do have color data. So, but I do want to, for the sake of this tutorial, kind of show you how you would go in and add color data. All right, so back into process, I'm going to colorize and then run. And we can get a sense here, for the kind of quality. So the big difference between like this and like the Trnio app, the photogrammetry, is that this is using, the camera on this object doesn't really have the same kind of obviously focus. It doesn't have the same kind of resolution. It's, more of not an afterthought, but it's, it's intended, it was built to just put a live video stream into video games. So it's not really, it doesn't have that kind of crunchy color, which you'll see. I'm going to do a side-by-side comparison. So then I'm going to do the same process. I'm going to test a couple different exports. I'm going to say export model. I'm going to use the OBJ per vertex, and it will include the color data. This per vertex, I've been able to get the color data out with Blender, but it's been kind of spotty with Maya. So I want to test that. So I'm going to say color and then per vertex, and then save. And then I'm going to export this. Actually, I'm going to kind of leave it as is. And then I'm going to, I will test the per vertex, but when I go, I'm going to test the texture UV, but when I use this option, it reduces the polygons to 20,000 faces. So I don't want to do that yet. The next thing that I want to do is actually, now I've colorized it. I want to go back into my process area, and I want to create a watertight model. I'm going to say very low smoothing so I can retain as much detail as I can, and I'm going to say run. And the watertight model basically does exactly what it kind of sounds like. It creates a model with an interior wall and an exterior wall that meet and join in a way that like if you fill this interior and exterior wall up, you could hold water without it dripping out. So that means that it's going to fill any holes in the mesh. It's also going to get rid of any non-manifold geometry. And so that's like geometry that kind of folds in on itself, where there's kind of like complicated wall issues. So it smooths that out into like a single like skin on the inside and the outside. That was not what I meant to do. So you can see here, it's filled in the bottoms of the shoes here, but kind of its best guess, like here's where it was getting data. And then here you can see like the kind of line where I cropped the shoes, and it still has a hole like through it, but that kind of skin wraps around each side of the hole, so that like if you did fill this model with water, it would hold it. So there's our watertight version. I'm going to do the same thing. I'm going to share export model as the OBJ per vertex, and because I want to go to default, and then I'm going to call it watertight. And then save. And now I'm gonna export this model as per vertex with the, not per vertex, with the UV map. So I'm gonna say export model and then OBJ texture UV. So we'll be very slow with decreasing the number to 20,000, which should be enough in most cases. I'm gonna see if I can override that. I think it was somewhere around like 90. And it might be very slow. So we'll see how that goes. And this is texture. And it's going to make a couple files with this one, images and a material file. Okay, so that wasn't too bad. Actually kind of impressive. So now what I've got here, let me show you my Finder window with these scans. Download scans, Nike Scan 3. So these watertight, this is the kind of image map that Skanect has created for the shoe. So that's basically all of the kind of color data. Here's my test from before, a little preview. The material file, it kind of sits in between the OBJ file, which is the geometry itself, and then any of the kind of auxiliary material files or texture maps. And it's basically like the conductor. It's like, you image, go to that vertex. In these kind of embedded per vertex, the color data is actually, you can see even in the preview here, the color data is actually kind of embedded with each vertex information. But again, that different modeling programs will play nicer with that than others. So now now that I have these files, what I'm going to do is import them into Maya, so we can kind of get a sense of them side by side. Okay, here I am in Maya. And so to import OBJ files, go to File, Import. Then it's going to bring up your Finder window. I'm going to go up one level into my Nike Scan 3. And then I'm going to import the Nike OBJ. So import. And when I exported out of Skanect, I had an option to export in millimeters or centimeters, but we are working, I think, in centimeters in Maya, so that wasn't even an option. So I'm going to do all my scaling kind of in Maya. All right, so that looks pretty good. So I'm going to go, and I'm using my trackpad. You can tell it's super vagrant. So I'm going to just hard code the rotation data. It's set to 26. I'm just going to call it 25 across the board. And so I'm going to do that same scaling operation to all of the models that I bring in. Right, so Nike, and then the next one, file import, was the colorized Nike. Let's see, per vertex. And select, and we're gonna rotate -90. and then scale 25, 25, 25. And I'm gonna go into my textured view. Yeah, it doesn't really seem to be taking. Go into my attribute editor. Yeah, so I'm sure there is a way that I could go in and play around with the settings, maybe even like through Blender, but I don't think I'm getting textures with a kind of per vertex. So import Nike, we're gonna do the vertex watertight. And channel box editor. -90, 25, 25, 25. For some reason, that's also kind of changed the X location. And then file import. So for the texture versions, what we want to import is the OBJ file, not the material or the PNG. When you import the OBJ file, since it's in the same folder with the material file and the watertight PNG file, it's going to automatically search for those. So I'm going to say import. All right, so I can see that the color data is coming in, but it's kind of like a shiny material. So I want to, so this is kind of a wash, so this isn't working. So what I'll do is just go ahead and maybe I'll leave it in there just for consistency. So I want to change this. It looks like it's on like a shiny base material. So under my attribute editor, I'm going to slide over to the material. Yeah, and it's using a Fong, which is kind of like a pearlescent. I'm going to change that to Lambert. All right, so these are again, this is the kind of scan out of the box. Let me see if I can go into my orthographic side view. Okay, so here we've got a side by side. You can see we've got the original scan on the left. We've got the kind of my test for the per vertex OBJ color export that did not work. We've got the watertight and then the watertight that's been colorized. So you can start to see, like, even though I had low smoothing on, the watertight is losing a little bit of the detail, but it's getting a much kind of smoother texture. So that's kind of always something that you should be looking out for, like how much detail you want to preserve versus, versus like kind of a general smoothness, because there is just some erratic data that comes in, and you'll see that even more in the Trnio. So I'm going to import the Trnio now as well, so we can kind of get the side by side. And the Trnio comes in. I'm going to say import. When you, I used AirDrop to share it, so it came into my downloads folder, and then it comes in as a zipped file that I unzipped, and it's got this kind of, generic configuration of letters and numbers, but inside of it, you can see the OBJ file, kind of like we just discussed, with the material file and then the kind of textured JPEGs and texture files. The obj.obj is what we want to import. I'm going to say import, and it's come in and it's totally own orientation and scale. So I'm going to see if I can get that kind of lined up here with the other our other folks. Okay, so here are all of the objects kind of lined up. So you can see, the color data is by far on these, the Trnio scan is like far superior. It's just like so much more detailed, and that's just a function of the camera on the iPhone just being that much better than the RGB camera on the Kinect. The thing though is, it's this kind of fancy, the fancy image texture is sitting on top of like a base layer that is, pretty good, but like you can see there's a lot, like it didn't really get between the shoes that well. There's like a lot of kind of, artifacting from the reconstruction. It does details pretty well, but again, like the kind of watertight smoothing, that those details can end up providing, erratic data. But one of the things that it did gorgeous, I want to show, is that shoelace. Look, it got the kind of loop of the shoelace. And we can test, well, so it also, the program doesn't do the auto cropping. There is a kind of Trnio Pro version that I think might. So let's see. Cropping, I should have done a little bit better job of the kind of rotation. So let's see what these look like kind of rendered out side by side, so you can get a kind of sense for these apples to apples. So, oh, one thing I did want to mention, I'm going to turn the texture back on. So I talked a little bit about watertight. You need watertight models. So like starting here, these two are the watertight models. You need those in order to be able to 3D print, but also use any of the sculpting tools. So in Maya, we have some kind of very basic sculpting tools that I can use on like, the watertight models, but I cannot use on these other objects. So if I tried to, let's see here, select these shoes, for instance, that's the kind of colorized. See, I get this error down here. Sculpting cannot be performed on non-manifold geometry. So you can use a mesh cleanup, which maybe I'll try now and see how long it takes and what it does. And since I have these kind of two, that vertex test that didn't work out, it might be actually a good test to kind of see side by side. Here, so under this cleanup, so I'm gonna go, it's under mesh and then cleanup. I'm gonna go into the little white box, the options next. I'm gonna say cleanup, matching polygons, apply to selected objects, fix by tessellation. I don't think I need any of that. I want to remove any non-manifold geometry. Click the default, I think, is the normals and geometry. And then I want to get rid of any edges with like 0 length. And this is the length tolerance. I'll do the same thing for the kind of faces and the 0 map area. And then I'm also going to get rid of any invalid components and see how that goes. So again, clean up matching polygons, keep construction history, apply to selected objects. I'm getting rid of non-manifold geometry, normals and geometry, and then getting rid of all of these edges, faces with 0 length geometry or map area, and then removing invalid components. So let's see how that, actually, I'm going to save this first. Save scene. As I mentioned, these are the types of operations that are kind of like, make sure, and I didn't create a default workspace. So that's also kind of really important, especially once we start getting into external data. So I'm in my scans, I'm in my Nike Scan 3. I'm going to set the project, create a default workspace in that folder as well. And then I'm going to save this as Nike Scan 3. Okay, so now my Maya file is saved. We'll hit apply. Okay, so practically speaking, I think it has been going for 25-ish minutes now. So it's possible that if I just let it continue to run, that it would resolve itself. But I'm thinking it's probably a done deal. So again, the 3D scanning programs like Skanect or Mesh Mixer. So I have a tutorial on how to kind of use Mesh Mixer to clean up 3D scans that I'll link to in the video description here. Those are optimized to do this mesh repair very quickly, very efficiently. So I could be running into memory issues, or my itself could just be stack. But I was able to, let me kind of, I'll stop that operation in a moment, but I was able to do a kind of a side-by-side render. So this is the original scan. This is the per vertex. This is the image texture, so reduced to 20,000 polygons with the image texture. Here's the watertight version of the texturized 20,000 polygon limit. And then here is the 3D scan out of Trnio. And you can kind of see here, oh, I'm at the end here. So here is, here are those same models rendered slightly above without the image texture. And then here's that kind of front view side by side. So you can see, each one of these programs has kind of, strengths and weaknesses, obviously. The 3D scan with the Kinect, the color is not great, but if you're scanning things, I've gotten okay results with glass. Usually it's kind of funny. Sometimes you need to, I've done tricks like use like chalk spray to give like a little dust of like a surface for the infrared light to bounce off of or to displace onto. But generally speaking, the issue with photogrammetry is you're totally light dependent because you're running, you're making 3D models from images basically. So you need consistent lighting, you need it to be light. Whereas with the kind of depth sense technology, and I'm going to test the Trnio Pro. It starts using LiDAR instead of the RGB color data. So that'll be upcoming. But right now, pros and cons to each. The other issue with the Trnio is that it's Apple only. So right now it only works on iPhones. So the Skanect works across platforms, but you do need an external sensor for it. So pros and cons. All right, I hope this was useful and look forward to catching up with you all soon. Take care. All right, so now it says Freenect sensor. It knows that I have the Kinect plugged in. And I'm gonna go in and just show you the record screen and come back to the details. So you can see here, it's getting both color data from the RGB camera, and then it's also getting depth data. So in the upper right-hand side, you see that kind of rainbow. Anything that's black is too close. So it has a range of, I think, 14 inches, and it stops reading information. And then I think you can see it's actually getting information behind me. Let's see if I can do this. No. Put it down, Rhonda. So one of the things that I love, so can you see up here, kind of behind me in the screen? I don't know if it's coming through.
Yeah.
You see that shadow? Kind of?
Yeah.
Like right here where my hand is? That's my infrared shadow. So each one of those little, each one of those little dots that you see is like one of the Kinect sprays. And so my hand here is blocking the spray. I love that. I love that there's like this light that I can't perceive. Okay, so when I get close, it goes to red. When I get too close, it goes to black. And then as I just like move backwards, it's cooler. So I want to make sure when I'm scanning that I'm in my what's called the bounding box. So this little like white box around me. I want to make sure that like I'm in the middle of it. So that looks good. So I'm going to scan myself just kind of by rotating around. You can also scan by holding the sensor and moving it around your object. So now I'm going to go back into the prepare option. So I'm going to say body size. That's going to set a default bounding box, that box that it's reading information at 1 by 1 by 1 meter. If I was standing up, I would want to do height times 2. So it's kind of a longer, taller box. And then this is just where it's going to be saving scans. So I can press start. And then I'm going to double check to make sure I'm mostly in the middle.
Can you choose where it saves? Like, could you have it saved to your desktop? Does it let you browse and choose or no?
What's that? Yeah, you can change where it goes. Yeah. So if I wanted to like save it to my desktop, let's go back to prepare, new. You can click on that and just select from your browser where you want it to go. So I could say like, whatever, documents, downloads. Put it in scans, say save. And then I'm going to say press start. And then all I need to do, so I've got it on a delay. When I'm self-scanning, that's good because I can kind of stop. You don't want to be moving around because the scan will lose its place and start deleting vertices. So whatever you're scanning, you want to be like not changing its relational position. You can like rotate, but you don't want the object's form to change, right? So it's got a 3-second delay, and I'm going to press record. And when I press record, then I'm going to kind of sit still and then just like move myself around in the chair. So 3, 2, 1.
So the camera is on, you know, you could the Kinect could be on a tripod, or it could be, in this case, I think on a desktop. Yep. And then Rhonda is on a you know, a chair without a back, or I guess with a little bit of a back, and just swiveling.
Ideally, you could, you know, those chairs, most of them, you can take the back off.
This is just so great as a performance. I just love this as a piece. Now you're going back. When you're done, I'm going to ask you why you swiveled back. Not now.
Okay, so so one of the reasons, so even when I'm trying to stay still, even just micro movements are going to delete and kind of change. See, like I deleted kind of my mouth, right? Like it ends up just kind of like, rawr. So one way I should have done that maybe is like start from the side and then turn around so that like when it's reading my face, it's only reading the face from my last position, right?
When
so
you go back, does it re-choose like what the best options are, or?
For like when it goes back to make the 3D model, you mean?
No, I noticed you swiveled, maybe this is my imagination, but I thought you swiveled back again and kind of like regrouped.
Yeah, so that's kind of like if I was doing this like for like my own uses or something, I would actually probably I would rescan because it cut off my nose kind of funny, and then the glasses are just problematic. I usually take them off if I'm going to be doing any sort of scanning. The reason why I kind of overshot and came back is because it's like rewriting. It's writing over top of the data that it had saved. And because like I'm turning around, I'm trying to be still, but I like move. So when I come back around to the face, I'm in a slightly different position, right? No matter how still I try to be. So I try to focus at the end a couple more scans around, just so that it can overwrite the data.
And Warhol, too bad he's not alive. He'd be so loving this demo.
Isn't it? I mean, like like when you say like just like watching the thing kind of fill out is so fascinating. So everywhere that it's green, it's receiving data, and then everywhere it's red, it's not receiving data. So it's either like it's confused about what it's getting, or it's like my hair, like right there around my hair, like the little sensor dot might just be kind of working its way through my hair, and it might not be getting the bounce back.
But look how great that is. Your eyes are now these orbits that's just waiting for the future, for seeing. I mean, it's just beautiful.
I know these broken scans, I just love the way that they look. So obviously if you're scanning for like somebody else and you're moving around them, you'd also want to make sure you get the top of their head, which I'll talk about when we do the handheld a little bit later. So
now the inside your head is like outer space. It's great. It's like you're like a galaxy,
right? Yeah. Like again, those parts that for like other people would be mistakes or errors, for artists, I see so much like artistic potential in that space. Ooh, I just found out that you can move that little zoom bar. Okay, that's great. All right, so once I've got it scanned, then I can bring it back into this process. And the first thing that if I was going to be 3D printing this, I could export as is, but I would actually want to probably get rid of the back of the chair. And like probably if I was going to try to 3D print this, I would need to get rid of those beautiful little shapes on the inside. And the way you would do that is in remove parts. So it's going to remove parts that are smaller than the largest 99th percentage. So it's going to get rid of that chair, and then maybe those things are actually connected in some way on the inside.
How did you get to remove parts? I'm sorry, it was quick.
Oh yeah. So first I was in record, and then up at the top here I went into process, and then this remove parts is one of these options that just shows up on the left hand side. And then move my little zoomer out of the way. The next thing that I tend to do is this move and crop. So that's going to allow me to kind of move my crop to a plane. So if I wanted like a flat bottom, I could like, you know, crop to that and say crop to ground, and it's just going to remove anything that's below that little blue plane. So now I have like a flat bottom, and then I could go into watertight. So when I go click on watertight, it's going to fill in all the holes. It's going to remove any geometry that's not 3D printable, and then it's going to colorize. So adding the color data back in. And that takes a little bit of time because it's, yeah. So here you can see like, yeah, it's kind of like two, it almost looks like, I was at an, it's like two, like my head just kind of moves. So
That's
it's like
the end of the day of teaching classes on
exactly. It's like pretty perfect. It's about how I feel. So it also kind of goes back and tries to do its best guess at like filling holes. So it'll use the color information from the last geometry that it has color data for, and just kind of extend that into both the bottom and then the top. And then once that's done, I click share, and then I export my model. I'm going to export for Photoshop as an OBJ, and then use this per vertex color, and then say export. And I'm going to say, I was doing it downloads and scans, new folder, scan. And then it's going to save both the model as an OBJ file, and it's going to embed all the color data in the model. Actually, you know what? I tried, did I try that? Yeah, for some reason, the export that I exported the vacuum that I did last class, Robin, when I imported it, even though it had the external files, it imported fine into Photoshop. So.
Oh, it did, huh? Cool.
There's always little like file format quirks. Know how yet? Do you see my screen?
Yeah.
Okay, so you, in the same process area in Skanect, you can go into simplify and then like drag down to like how many ever face number, whatever the face limit is. You can do that there.
Okay.
And then export. Okay, so what I done now is show you the process for the scanning, making a 3D scan with the Trnio app. So I start with Trnio, open the app. The home screen here shows me all the scans that I've made before. What I want to do is kind of go into this camera mode and make sure that I'm in AR Toolkit. And then I basically press record down here, this little record circle button, and move around the object. So I want to make sure that I move around it kind of in a 360 degree from more or less kind of shoulder height is where I stop. Make a little detour here. But generally speaking, I kind of make a pass around all the way around the object, as close to 360 degrees around the object as I can, shoulder height. And then I'll go in and kind of fill in like details where I want details. So for instance, here, like I'll go in at a little bit lower of an angle so that the app starts kind of making these 3D locators. And you can see all those little blue dots now are these like 3D positional locators that start, again, filling in the kind of relational data. So specifically, you can see here, you know, as I either kind of move into new territory or as I move the phone around in this kind of three-dimensional pass, it starts creating more relationships, right, between the objects, and kind of it will allow the Trnio kind of processor to make a much more detailed image. And then obviously you can kind of see you have the option of making these public. I think I've probably have my privacy settings turned up pretty high. But then it goes into this uploading image, and it uploads the images to the server, and then will process those images and stitch them back together. So when you open Trnio, you can see all of your scans that you've made. I clicked into the, let me kind of go back here. So I clicked into tapped this scan of my living room, and then when I tapped into that scan, then I get this preview that I can kind of move around the screen, rotate around with my finger, and then I click in the upper right hand corner here the share button, and then that it gave me options to share with this 3D mesh, an OBJ file, Sketchfab. I chose the 3D mesh, the OBJ file, and then I get some options, right? So you can email it to yourself or whatever. I just used AirDrop to send it directly to my computer. And that's where we kind of leave off, and I'm going to jump back into showing you what happened from my computer. Okay, so what I'm going to show you, there are two modes in the Trnio app for scanning. So when you go into this kind of camera mode, there's the object and ARKit. And the object is for objects, so things that you can walk kind of in a 360-degree movement around, kind of looking at the object. And then for more environmental things like, larger than human, but kind of up to small building scale, the ARKit is good for. So this is showing you the object mode. And so for this, you can do it a couple different ways, either allowing like walking around the object. So here I'm just going to kind of start from around shoulder height, looking down at the object, start the record, and then it's the app automatically takes photos as you kind of move around the object. So the goal here is to kind of rotate around the object from different heights. So I'm starting here at shoulder height, and then once I get around all the way around to the front again, I'm gonna I think I move down to more or less like hip height, kind of looking directly on, and then I do a pass from above and then a pass from below. And I'll probably speed this up a little bit. Or I can tell you, you can either walk around the object like I'm doing now, or you can put the object on like a rotating plinth or something. So either a lazy Susan or a mechanized rotation device used especially for 3D scanning. And we have a couple of those at San Jose State that hold, I think, up to like 200 pounds. Okay, and you can see the kind of completion rate here as we kind of get around the scene. It like tells you that you're almost done, and then as soon as you finish the kind of last photos, it says, would you like to create a scan from the images? You say yes, and then it's saved locally and then placed, uploaded and then placed in a queue, and then you download it the same way you would with the for the process with the ARKit that I showed you.
I have a couple questions.
Yes.
How important is it for the object to be on a neutral background?
Not at all.
And is lighting something that you need
Yes.
to consider?
Yes.
Rhonda,
So
I was trying it, but all the little speckles that show up when you're scanning, is it only the object or other things get kind of scanned around it? I'm confused about that.
so like you'll see, actually, Lauren, hold on before you go. I'm going to answer a couple of these questions with like I'm going to share my screen. So share this one and Photoshop. So when I took this scan, for instance, still getting the hang. See that little circle below the object? That's like the floor, right, that it took. So it does take, like, it does its best guess at like what the footprint is, and it kind of edits out information. So while I was scanning, you probably saw like it might have gotten blue dots on like my desk or my plant or like other things. But when the images are analyzed on Trnio's server, it does a really good job of saying, nope, we don't need that. And it really just compresses it down to a very small footprint. It might be the case that you get some strange artifacts and some floaters, but Trnio has been really, does a really elegant job of kind of cropping out. As far as like neutral backgrounds go, it doesn't, like you could scan, like I don't have, a clean background back here, right? Like I'm scanning, this is my setup right here, right? So it just happens to be that I wanted it on the floor so I could walk around it. That's the biggest issue, is having enough space to walk around your object. I haven't tried it yet with a spinner. So when I'm using my 3D scanner, that Skanect, I actually put the objects on a Lazy Susan, and I kind of hide under the Lazy Susan and just kind of like, turn it with my finger so the objects are actually rotating. I haven't had great results with the Trnio app and that as a model, because I think it needs a little bit more location data to like hold on to. And it
So
also probably really depends on the model.
So you feel with Trnio, it's better to walk around the object than have the object move, whereas I suspect Lauren's gonna show something different.
Exactly. So with the Trnio, I was really optimized for a static object and a person kind of walking around it.
Okay, so you should be able to hear the audio later on when it goes. Everything's popping up. Okay, so this screen, let me just turn on the lights, is your screen that pops up when you open the app. It has the home, it has the scanning option. So you press the middle button to scan, and then it prompts you, here's some scans I've done already. So let me demo a scan. So then it's gonna walk you through.
Scanning is a two-step process, and we'll start by scanning your head. Make sure you're not wearing glasses.
So it will walk you through it every single
Hold the
time.
phone vertically
And because
fit
the
the
lighting,
face into the oval.
it's a little picky on the lighting, so I have like 2 lamps that are here so that it will actually pick up. So usually you should take off your glasses, pull your hair back. I've had decent results on both, so I'm going to just leave my glasses on but keep my hair pulled back for this one, and then you can try if you with or without whatever works, but it's kind of like a trial and error because of the 2-parter. So this is the first part where it scans your face, and then the second part will scan your body. So you have
Please
this,
look
and you
into
have
the
to line it
camera.
up to your
Turn
face.
to the right,
And then I'm following the
back to the middle,
instructions.
left, middle, up, middle, down, middle.
So then that basically checks, sees and scans your face. So then here's the body part.
Hi, this is a quick guide on how to
Run
make
through that one. It asks how tall you are, so I'm very short, so I'm gonna keep it like that. And you just want to find where your hips are and have your phone. I'm using a tripod so that I can.
Here's a quick reminder on what you should do. Place your phone on a surface at the level of your hips at an almost 90-degree angle. Then step away from the phone. You should see your
It will
head
say
near
that
the
you
top
can't
of the
light.
screen
So
and
I'm
your
gonna
feet
step
near the
back.
bottom of the screen. Your full body should be in view. Put your
So-
legs wider than your shoulders. Your arms should be at a 45-degree angle to your body with your fists clenched.
So it would be around
Remember
here. You
this
want to make sure
position.
that you can see your feet.
Then press the
You
white
lift up
button
your
to start
hands
scanning.
out at the
You will
side,
have 5
and your hips
seconds to
will
get
go,
back into position.
to be a little wider than your shoulders. And because it thinks it's always low light, my trick is just kind of like moving out of the way so it thinks that it's not low light. And then you have 5 seconds to run over. So I'm going to press it.
Here's a quick reminder.
So
Here's a quick reminder on what you should do.
it
Here's a quick reminder on
does
what you
that
should
because of the
do.
lighting, so I'm
Place your
gonna
phone
put it
on a surface at the level of your hips at an almost 90-degree angle.
Okay.
Get back
I'm not
into
gonna
position.
like rush over.
Now turn around 360 degrees.
And then
10,
rotating.
9, 8, 7, 6, 5, 4, 3, 2, 1. Finished. You
Oh my
can
God.
move freely now. Please
And
review the
you
video
view
and
your
rescan if something went
footage.
wrong.
And you make sure that you're standing in the correct position, that you didn't look weird or something. It will take a second. So I say that's good enough. You want to make sure you have everything working. So I'm going to hit the check mark, and it's going to upload the data that happened. You want to make sure you don't get out of the application just to make sure, because sometimes I've had issues where I walked out of the application and it didn't work uploading wise, but that was a lot faster than it was earlier.
Wow.
So it will tell you a notification. So this is the point where you can press OK and go do whatever you want while you're waiting for it to upload. Because if you check, it's, oh wow, okay. It says only 6 minutes. When I first started using it, it said it was going to take an hour. So it varies as well, server base wise. And I've done a couple scans just testing to see how long things would take. So I'm just going to go back to one that I know is pretty decent for while we're waiting.
What if you don't want to have your arms down? What if you want to be shaking somebody's hand, or what? What happens if you don't stand like that?
So this pose, kind of like the augmented T pose, is like for character developers who end up, developing characters for like 3D animations or for games. This is like gives you the most data, right? Like around your model. It also makes it really easy to rig. So that like rigging is where you put like an internal skeleton inside of this geometry, the mesh, and then bind the mesh to the skeleton so you can like make a puppet more or less. So I don't know if it would scan, because it's like the algorithm again is like, it's amazing that like it's taking somebody who's like moving, and like turns it back into a scan. So like if you're not in that shape, I don't know that the algorithm would catch it. Have you tried, Lauren?
I tried slightly different things and it wasn't capturing as well. Like it doesn't matter in theory if you're just having a static object, but in this, while you're viewing it, it will say, oh, downloading, and then you get to this point, and then I think they're either partnering with Mixamo, which is a great service to use. It's through Adobe, and it will have rigs of animations that you can just plug and play and make them work out. So what it did is downloaded the model. So I'm gonna just spin it around so you can see the model. But also on the bottom, you see that there's like positions. So if I just tap one of those, I am in a weird position.
So this is kind of like using like the rig to pose it. Yeah.
And this is what you said you could do it in some application in Adobe, is animate yourself like that. What do you push? Like?
I love just like the blank face too. It's so good. Just like mildly amused. So wonderful. Yeah, so the In3D is optimized for scanning people. The Trnio does objects pretty well, though for like room size environments, I think it can do like a wall or a corner, but like not like an entire room. Have you tried, Lauren, to use Trnio with a larger scale?
Yes, I have showed you, and I can show as well when I scanned part of a building. I just want to go over really quick about there's like some buttons on the top. So the top right, you can have your body measurements if you do a little bit of extra stuff. There's a version that you can just see yourself in augmented reality. The Discord button if you want help, because if it's not working, you have that going on. And then of course export, which you'd use. Would you like me to show you the Trnio stuff right now or later?
Yeah, do you have it available?
Yeah, I just got to open that. So I'm gonna stop sharing so you can like do any other things PowerPoint wise while I open it up.
Yeah, we'll come back to you. So I'll show the import process. I'll check in on my, let's see.
So the in 3D, this one, can you also import it into Photoshop, or is it best to be imported into things like Blender or After
Yeah,
Image or something to animate, or how is that?
Yeah, Lauren, can you show the export process?
Oh yeah, I can do that. Let me open that back up instead of having it in Trnio. So share screen. Okay, is it going? We're going? Okay. So then just export. And then you can go and choose whatever you're going to, your contacts, go through, email yourself, and it'll be a zip.
Can you email it to me?
You can do a zip to email, and then you can have your file and everything. I think other things would ask if you use a different application, they'll have a URL that you have to send to yourself and then click it, and then it will let you do the whole thing for the zip file. So you would just email it to yourself with this one, and then you can just open the zip file when you're done.